this is going to be short because, again, we're just doing the inverse, just like we did with parallelograms. Um, we're finding the reasons that not only do these, yesterday we learned that the shapes had certain characteristics. Now we're doing that these characteristics can prove that it's a given shape. So, for instance, for rectangles, we have if it's a parallelogram with one right angle, then it's a rectangle. If you can prove that you've got a parallelogram with congruent diagonals, then it's a rectangle. If you can prove you have a parallelogram with one pair of consecutive sides, or consecutive congruent sides, then you have a rhombus. And if you prove that you have a parallelogram with perpendicular diagonals, then you have a rhombus. And if you have a parallelogram with diagonals that bisect opposite angles, then it's a rhombus. Okay, so all of these characteristics will prove that we've got rectangles. So you can kind of see like what we did with parallelograms. Now we're going to do coordinate proofs that prove some of these things are true. Okay, so, oh, and the other thing I need to mention is for squares, you just have to prove one rectangle thing, one of those rectangle green ones, and then one rhombus thing, one of those orange ones. Okay, if you can prove one of each of those, because remember squares are both rectangles and rhombi, so if you can prove one of each, then you know you have a square. What I'd like you to do is on a separate sheet of paper, preferably not your notes, because I'm worried that I'm going to write on your notes or something and mess them up. So if you can do it on a separate sheet of paper and tell me for 1, 2, and 3, what are they? Rectangles, rhombuses, or squares, or just a plain old parallelogram. And then tomorrow we'll work some more on proofs.